Hi everyone, I hope you're all having a lovely day off. I had received a request to go over an additional example of a paragraph proof, particularly one that used the midpoint, since you are working with a homework assignment that uses a midpoint for a paragraph proof. And additionally, it's a good practice to see another one and to see how you kind of go through the process. So let's go through this particular problem. And I will be very explicit in terms of what I write out. When you are writing them out, I'll kind of try and show some ways that you can combine steps, and I'll let you know if there are any steps you could combine. But I'm going to write out everything, all right? So let's just kind of read through this and do a little bit of pre-planning here, or planning ahead, I should say. Given that segment BC is congruent to segment EF, M is the midpoint of BC, segment BC, and the N is the midpoint of segment EF. Write a paragraph proof to show that BM is equal to EN. So our ultimate goal here is to show that these two are congruent, right? That's our goal. But what do we already know? Well, we already know that these two entire things here, these two whole segments, we already know that they're congruent. And we're also informed that the M is the midpoint, so we know that these two are congruent. We know that N is the midpoint, so we know that these two are congruent. All right, so given the fact that we have midpoints, it's going to be essentially able for us to simplify things into, the whole line, the whole segment is equal to 2 times BM, right? Because BM plus MC is BC, and then they're the same, so you can combine them. So that's kind of where things are going to ultimately come down to. And as you do more work with midpoints and get more used to some of the general formats that you'll see that we approach, you'll kind of know ahead of time that's probably where you're going to have to end up. All right, so let's go through how we will actually do this. So it is Wednesday, so I probably should be writing in pink. Okay, so ultimately, given that BC, segment BC, is congruent to segment EF. All right, so I'm going to start with that piece of information. So, that's not pink. Since BC is congruent to segment EF, right? Since we already know that, BC is equal to EF by the definition of congruence. Okay, so you're probably looking at this and saying, well, why am I using two reasons on this, right? With only one statement. So this actually up here is saying, since we already know this is just how I'm reporting out my given. So that doesn't actually relate to the rest of it. That's just saying, we're already given that information. And then this part is actually my statement and my introduced statement and my introduced reason. So I'm saying this is my statement, BC is equal to EF, and then my reason behind that is that's just the definition of congruence, right? We know if two segments are congruent, their measures are the same. Since M is the midpoint, all right, so since M is the midpoint of BC, right, well, what does that mean? So this is just, again, we're reporting our given. Now I'm going to introduce a statement. BM is equal to MC by the definition of a midpoint. Okay? So ultimately, all we're doing here is we're just saying that segment BC has a midpoint, it's M. Well, what can we ultimately figure out from that? Well, we can say that these two are equal to each other because that's just what it means to be a midpoint. And now I'm going to use the exact same argument to make another statement now about N and segment EF. So what I'm going to do is I'm going to use the lovely wonders of mathematical hand waving of, you're just going to have to do the exact same thing over again. So I'm just going to skip over it by saying similarly. Okay, so if you just did something and it's going to be the same argument, you can use similarly. En is equal to NF. All right, so we were able to do that again just because these are going to be the same argument. We have the same pieces of information given, just with different letters. That's all. That's why I'm able to do that. Like if it's not totally clear, don't use similarly, but that one should be relatively clear since I just did it for this one and we know these are the same. Now, ultimately, our goal is to get to BM equal to EN. So that ultimately will mean that we have to relate these two segments to each other. Well, we already have a way of doing that. We already know that BC and EF are related to each other. They're equal to each other, right? So I need to get my BM and my EN in terms of my BC and my EF. So how can I do that? Well, we know that M is between them. We know that N is between these two. So I can use my concept of betweenness. So by betweenness of M and N in segments BC and EF, and I'm not putting the lines over them because I already used the word segment, so I don't need it. So all I'm saying, by betweenness, so I'm saying this is between these two and N is between those two. We know from our prior information about betweenness, BC is equal to BM plus MC, and EF is equal to EN plus NF. Now, again, what you could have done here is you could have actually broken this up into two different statements and reasons. But ultimately, again, these were going to be ones where they have the same argument, so you could have used a similarly afterwards, but I just put it all together in one. That's totally valid. That's perfectly fine. When we get to two-column proofs, you're going to see that we can, if they're going to have the same reason, you can just kind of combine them into one step. So that's perfectly valid. If you would feel more comfortable just writing them out as two separate ones, go for it. All right, so now what do we know? Well, we know that BC is equal to this mess, and then EF is equal to that, but we know they're also equal to each other. So and remember, when we're setting things equal to each other, I shouldn't talk right, substitution, right? So we're saying when we're setting them equal to each other, we're substituting them in for each other. Substitution. So by substitution, BM is equal, BM plus MC is equal to EN plus NF. So again, really all we did was just set them equal to each other because we knew up here they were equal, right? All right, now what can I do? I can do more substitution because we know NF and EN are the same, and we know that BM and MC are the same. So further substitution gives that EM plus BM is equal to EN plus EN. Okay, so at this point, you're probably wondering, why did I just not combine them? Right, I could have just written it as 2BM and 2EN. You could just go right to that. It's pretty obvious that that's going to happen. But for clarity, for us seeing this, I felt it better to write it all out. This is one of those instances where I said you could kind of combine some steps, and this step and the prior step, the one that I just wrote, ultimately you can't combine. So write a final substitution. So final substitution gives 2bm equaling 2en. And then finally, by division, em equals en. Okay. So ultimately, my final thing here is what I was trying to show, that bm was equal to en. So I am done here. I've used all of my givens. Fun fact, if you're given information, you're probably going to use it, so you should. Otherwise, you wouldn't have gotten it. But ultimately, I've used my givens. I've ended where I wanted to end. I've done everything explicitly. So I am done with this. Again, you can either put the little box, you could put QED. But ultimately, what you should take away from this is a lot of times when you're dealing with midpoints, you're going to kind of end up in a scenario where you get something like this, where you have 2 BMs equal to 2 EN, or 1/2 of the original one is equal to 1/2 of the other one. And then ultimately a division or a multiplication is kind of canceling things out. So that's a very common occurrence for midpoints. In particular as well, the idea of using, this plus this and this plus this, and well, these all added together make the whole, the parts together added make the whole. That's another common occurrence that will happen in proofs, particularly with segments. So anyway, please let me know if you have any further questions about paragraph proofs. I hope this helps, and have a great day.